So now what we want to do is we want to test for symmetry. We know what it looks like. We want to see. We have an equation. We want to see what it is. So if I want to test with respect to the y-axis, remember what we said, that we had if x was on it, so was xy was on it, so was negative xy. So what we're going to do is we're going to replace x with a negative x in the equation. And if the result is the same equation, then it is symmetric with respect to the y-axis. All right, so let's think about y equals 3x to the 4th minus 5. If I put in negative x, well, it's 3 times negative x, the whole thing to the 4th minus 5. Since that's even, then it becomes the same thing, so that is true. Okay, with respect to the x-axis, same thing, except now, remember what happened with the x-axis, we changed the y. So I'm going to replace y with negative y. So an example would be x equals 2y squared. Well, now if I say x is 2 times negative y squared, that's the same thing, because when you square it, it becomes positive. So that equation is symmetric with respect to the x-axis. Now with the origin, same idea, but now I have to do two replacements. I have to replace x with negative x and y with negative y and see if I get the same equation. So let's look at here. I have y equals 4x to the 5th. Let's see if this works. So I'm going to put a negative y here, 4, negative x here, and when I raise it to an odd power, that's the same as negative 4x to the 5th. So if I have a negative here and a negative here, what happens to them? They go away, right? It's like if I multiply or divide everything by negative 1, and I get y equals 4x to the 5th, which is what I started with. Now let's try this example, test for the 3 types of symmetry. So first I'm going to replace with negative x. So this is y equals negative x squared minus 9, negative x squared plus 2. That's the same as even, right? Negative times a negative is a positive. And x squared minus plus 2. So it is with respect, use WRT for the respect to x-axis. Let's try the y-axis. So now I put negative y, and I have x squared minus 9, x squared plus 2. No, it's not. Now what if I put in negatives in for both? Try the origin. Let's try the origin. So I put a negative y in and a negative x. And no, it's not, because this goes up to what this was, and this one's there, and it's not the same as the original problem. Okay, the last thing it says is let's look on a calculator to see if we can check it. So we're going to go to the calculator. So I'm going to put this equation on the calculator, and then I'm going to see what it looks like. So I'm going to put in parentheses, and then I want x squared minus 9. I go outside my parenthesis, and then I'm going to divide, and I'll do a parenthesis again, and I want x squared plus 2. I'm going to press enter, and there's the graph, and it definitely is symmetric with the x-axis, but not the y and not the origin.